Hi, this is Alex from devstories.eu. GitLab CI/CD, Episode 4 of 14. Hardcoding an API key directly into your pipeline configuration is the absolute fastest way to compromise your entire production environment. You need a way to pass configuration and credentials into your jobs dynamically without exposing them to anyone who can read your repository. CI/CD variables and secrets are the mechanisms that handle this. Whenever a GitLab runner picks up a job, it does not start with an empty state. GitLab automatically injects predefined variables into the environment. These give your script immediate context. You have access to variables like CI commit branch, the pipeline ID, and the project name. You do not define these, they are simply there, ready to use in your scripts to route logic or tag build artifacts. Beyond the predefined context, you will need to supply your own custom variables. You can define these in two places, inside your YAML configuration file or in the GitLab user interface. The rule for choosing where to put them is straightforward. If the value is safe to read, like a compiler flag or a development server URL, put it in the YAML file. The configuration stays with the code. If the value is sensitive, like a database password, define it in the GitLab project UI. When you place a secret in the UI, you have to configure its security boundaries. People frequently mix up masking a variable and protecting a variable. They are completely different concepts. Masking a variable prevents its value from appearing in the logs. If you mask a database password and a poorly written script tries to print it to the console, GitLab intercepts the output stream. It replaces the actual text of the password with a string of asterisks before the log is ever saved. Masking controls log visibility. Here is the key insight. Masking does nothing to stop a developer from writing a script that sends the password to an external server. That is where protection comes in. Protecting a variable limits its availability. A protected variable is only injected into pipelines that run on protected branches or protected tags. If someone opens a merge request from a standard feature branch, the pipeline may trigger simply will not contain that variable. This prevents untrusted code from accessing production secrets. Additionally, you can use hidden settings in the UI for extreme sensitivity. Once a variable is saved, its value is obscured in the interface. Even project maintainers cannot easily retrieve the raw text later, meaning someone with access cannot just casually scrape the settings page to steal all your tokens. Now consider how the variable gets to your application. Most variables are injected as standard environment variables, but some tools refuse to read environment variables and insist on reading from a physical file. The AWS command line interface, for example, often expects a formatted credentials file residing on disk. Instead of writing a pipeline script that creates a file, dumps the variable text into it, and then tries to securely delete it later, you can use a file type variable. When you configure a variable as a file type in the UI, the runner handles the logistics automatically. When the job starts, the runner takes the text value, writes it securely to a temporary file on the runner disk, and sets the environment variable to contain the file path, not the file contents. You simply point your AWS tool at the path provided by the variable. When the job finishes, the runner destroys the file automatically. Securing your pipeline is about minimizing exposure at every step. Do not rely on log masking to protect against malicious code, and do not write temporary credentials files yourself when the runner can handle the lifecycle safely. That's all for this one. Thanks for listening and keep building.